Hello everyone and welcome back to the DAO Adventure. My name is Sebastian, I am Education Lead at Golden State and I'm here to help you build a DAO on the internet computer in 7 days. Today we are building a token for our DAO. This is project 3 out of 5 from the DAO Adventure / training phase. If you are not familiar with those 3 phases, we have the initiation where you deploy your first application, the training which is an optional phase but strongly recommended. In this phase, I will guide you through 5 different projects. Those projects are written in Motoko. And finally, the end goal of the DAO Adventure is for you to graduate, which is to build and deploy your own DAO and earn your Motoko Bootcamp Diploma. So our mission today is to build a token for our DAO. This is essential because a DAO is an economic structure. We need a token to incentivize community members to participate and also to reward the most active builders and the most active community members. Alright, so we are on project number 3, supercharging your DAO with economic power. As always, I have my project.markdown open on the right and my Motoko file open on the left. Let's quickly read the story for today. So today you are walking through the academy, you hear noises coming from behind a door and you decide to see for yourself and enter a giant room. In this room, you see screens coming alive with graph and data illustrating the flow of tokens within various DAOs and markets. This is like the New York Stock Exchange, but for DAOs. And that's when you understand that tokens are the lifeblood of DAOs. Tokens are more than just digital coins. It's about recognizing and rewarding contributions, big or small, ensuring the sustainability of the dream. Everyone is building together and giving this dream a structure. With every step you take, you understand a little bit more about the essence of DAOs. DAOs are not just about dreams or communities, they are also about fueling those dreams, supporting a community, and giving it a structure. The token is the fuel. This is why it's time to supercharge your DAO and build a token. Today, our mission is to implement the code for a token. It can seem like a big and scary mission, but on the internet computer, we can simply create a token by creating a canister. This canister will store the balances of our users and will also be able to deal with transfer, mint, and burn. Assuming this canister is decentralized, so assuming this canister is not controlled, we can consider the token to be safe, trustless, and decentralized. Okay, so the requirements. In a real-world scenario, the mint function would be restricted to a specific set of identities. For the sake of simplicity, we will not implement this restriction. The same applies to the burn method. So we have mint and burn are open to everyone. Anyone is able to mint token, anyone is able to burn token. Of course, this is not realistic and this is not secure, but today we are simply building this project as a training. For the requirements, our token needs to have a name and a symbol. The token has a total supply, which we can query from the total supply query function. Anyone can mint tokens, as we've said, anyone can burn token, anyone can transfer tokens to another person, assuming they have enough tokens. Those are the tasks for today, so we have to define a variable, we have to complete all the functions, and finally, so we have 7 tasks for today, and finally, at the end, we have this interface. We have this interface with those following functions, so we can take a look at them: token name, token symbol, mint, burn, transfer, balance of, and total supply. So as you can see, those are all the methods that we have here. Today, we don't have specific types except the result type that we've already seen, but we don't have new types. We only have types that we already know. So we have the type principal and the type natural number and text. Now is the time for you to pause this video and try to implement the 7 tasks that you have for today. I'll see you in the next part of the video, which is the correction of this project. Good luck. Alright, so let's move to the correction. I hope that you successfully implemented all the functions. If you have not, don't worry, I'm going to correct everything and explain how I'm doing it. The first task is to define a ledger variable. This variable will be used to store the balance of each user. The key of the ledger variable is of type principal and the value is of type nat. So we essentially need to implement a hash map. Again, we could also use a tree map for this one, but I will stick with the hash map that we've already seen. We need a ledger which is going to store for each principal, so for each user, a balance of type nat. So this is how we are implementing a token. It's simply a hash map that associates principal with natural numbers. So to define our hash map, hashmap.hashmap, principal and natural number. The initial capacity will be set to 0, and if you remember, we are using two functions, principal.equal and principal.hash. We have the same keys as in the project number 2, so we can use the same methods. That's it for task number 1. Let's move to task number 2. We need to implement the token name function. This function takes no parameters and returns the name of our token, so we can implement a variable which will be let name of type text will be Motoko Bootcamp token, and we simply return this variable in the token name function. That's task number 2. For task number 3, we need a symbol. So let symbol of type text. A symbol is usually 3 characters in length, so we will use MBT and return the symbol here. Now we need to implement the mint function. This function takes a principal and a nut as an argument, and it adds the nut to the balance of the given principal. You will use the result type for your return value. So what we need to do is essentially add the amount that is specified to the balance of the owner. The first thing that we want to do is to get the balance of the owner, and for that we can use a trick. We will use option.get, ledger.get owner, and 0. So let me explain what option.get is about. First, we need to import the option module. The option is a module from the Motoko base library that is useful to work with optional value, as the title indicates. And the first function from this module is option.get. Option.get is a function that can be used to unwrap an optional value. So essentially, you can specify an optional value, and the second parameter will be a default value. It can be of type nut, it can be of type text, it can be of any type. And if the function, the argument that you specify in the first parameter is null, it will return the default value. If it's not null, it will return whatever value is inside. Essentially, what we are doing here is looking at the balance of the owner. So is there a balance for this principal? If there is one, then yes, return the balance. If there is not, then by default, the balance of this person is, of course, 0. So that's how we got the balance. And then we can do ledger.put for this principal. We will do balance plus amount. So this function works in case the balance is 0, but it also works if the balance is not 0. And once we have done that, we can simply return OK. Now let's implement task number 5, which is implementing the burn function. The burn function will be similar to the mint function, but this time we actually need to check that we can burn the specified amount. So we need to verify that the amount that we want to burn is below or equal to balance of owner. If it's not the case, so essentially if we are in the other case where the amount is above, we can return an error. This principal doesn't have enough token to burn. Otherwise, we can do ledger.put, so owner balance owner minus the amount. So we know that this will be positive because we can only have a nut here. And finally, we can return OK. Now, the next step is the transfer method. So for the transfer method, we can also use this trick of option.get. We can do balance from is equal option.get ledger.get from and then 0. And balance to is option.get ledger.get to and 0. And here we should use .get. We need to make sure that the balance from is enough for what we want to send. So essentially, if balance from is below amount that we want to send, then we should return an error. This error will be the from balance is not enough for this transfer. So essentially, we are about to transfer this specific amount from this specific account, and if the amount in the account is not enough, then we cannot proceed the transfer. Otherwise, we will simply do ledger.put balance from, which would be balance from, so no, it's gonna be from balance from minus amount, ledger.put to balance to plus amount. And we can finally return OK. So we know that this will be a nut, and of course this will be a nut as well. Task number 6 is to implement the balance of. This function takes a principal and returns the balance. It should return 0 if the account does not exist. So essentially this is the trick that we already have done, option.get account and 0. ledger.get account. So this option.get method is really useful here. We can return that, of course. Finally, the total supply. This function takes no parameter and returns the total supply of your token as a NAT. For that, we can simply do a variable total balance, which we will initialize to 0. And then we can do a for loop over our hash map. So to do that, we can do ledger.values for value. So for balance in ledger.values. So here we are iterating over our hash map and essentially iterating over all the possible value of type NAT, so all the possible balance of all accounts. Then we can do total balance is equal to total balance plus the balance. And so as we know, we are iterating over every balance, and so we can return at the end of this for loop the total balance, which corresponds to the total supply. And that's it for the project number 3. Now we can deploy on the playground. As always, dfx deploy -- playground project number 3, and we can test this token from the Candid UI. That's the Candid UI of our token. So we can check the token name. This is correct. We can check the token symbol. Right now, the total supply should be at 0. We can create some balance for our principal, and for that, I will dfx identity get principal. So this principal, which we'll reuse as a test. I'll create 100 token, and now we have 100 token in this account, so we can check 100. I should be able to use another identity. So if I take a look at dfx identity list, right now I'm using default. I could dfx identity new test storage mode equal plain text. And so dfx identity use tests and dfx identity get principal. I can use this principal for a test. I'll transfer from this principal to this new principal. I'll transfer 40 tokens. And now I should be able to check my balance, which should be 60 for this one and 40 for this one. The total supply should be 100 still. And if I query from dfx, it should be the same. So dfx canister call playground project 2, project 3. And we can call the balance of method. Here I'll need to specify a principal. So I'll specify principal, copy the principal, and then query that. And I receive 40. So it seems also to work from here. That's it for our mission of today. If you want to know more about tokens on the Internet Computer, you can take a look at the ICRC1 standard, which is the official standard to build token on the Internet Computer.